Assalamualaikum. My name is Intan Rashikin binti Uzi. My matric number is 11 DKA 18F 2009. I am from DKA 4A. Today, I want to study about the behavior of fluid flowings in pipes. I want to define about steady flow and unsteady flow. Steady flow is one in which condition, that is, velocity, pressure, and cross-section may differ from point to point but do not change with time. Next, unsteady flow. Unsteady flow is if at any point in the fluid the condition change with time, the flow is described as unsteady. In practice, there is always slight variation in velocity and pressure, but if the average values are constant, the flow is considered steady. Next, state the Reynolds number formula. How to get Reynolds number? There is two ways. First, Reynolds number is equal by density divided by dynamic viscosity times velocity and diameter. Second, Reynolds number also equal by velocity times diameter divided by kinematic viscosity. Next, how to get kinematic viscosity? Kinematic viscosity equal by dynamic viscosity divided by density. Next, identify the value of the Reynolds number. Fluid friction loss chart. Fluid flow in a pipe encounter frictional resistance due to the internal roughness of the pipe wall, which can create local eddy current within the fluid. Calculation of the Reynolds number helps to determine if the flow in the pipes is laminar flow or turbulent flow. Pipes that have a smooth wall such as a glass, copper, brass and polyethylene cause less frictional resistance and hence they produce a smaller frictional loss than those pipes with a greater internal roughness such as concrete, cast iron and steel. The velocity profile of fluid flow in a pipe shows that the flow at the center of the stream moves more quickly than the fluid flow towards the edge of the stream. Therefore, friction occurs between layers within the fluid. Fluid with a high viscosity flow more slowly and generally not produce eddy current, thus the internal roughness of the pipe has little or no effect on the frictional resistance to flow in the pipe. This condition is known as laminar flow. I want to explain about laminar flow, turbulent flow and transition flow. Laminar flow generally happens when dealing with small pipes and low flow velocities. Laminar flow can be regarded as a series of liquid cylinders in the pipe, where the innermost parts flow the fastest and cylinder touching the pipe isn't moving at all. Shear stress depends almost only on the viscosity, like dynamic viscosity, and is independent of density, that is rho. Reynolds number for laminar flow is below than 2000. Transitional flow. Transitional flow is a mixture of laminar and turbulent flow, with turbulent in the center of the pipe and laminar flow near the edge. Each of these flows behave in different manners in terms of their frictional energy loss while flowing, and have different equations that predict their behavior. Turbulent or laminar flow is determined by dimensionless Reynolds number. Reynolds number for transitional flow is 2500 within 4500. Turbulent flow. In turbulent flow, vortices, eddies and wakes make the flow unpredictable. Turbulent flow happens in general at high flow rates with larger pipes. Shear stress for turbulent flow is a function of density. Reynolds number for turbulent flow is above than 4500. This is some example question for Reynolds number. Water flows at the rate 0.054 meter cube per s through a 450 mm pipe in diameter. Oil density is 985 kg meter per cube. And kinematic viscosity is 2.3 times 10 power of negative 4 meter square per s. Calculate. Berdasarkan soalan, flow rate diberikan ialah 0.054 meter cube per s. Diameter ialah 450 mm dan ditukar kepada 0.45 m. Density ialah 985 kg meter per cube. Kinematic viscosity ialah 2.3 kali 10 negatif 4 meter square per s. Soalan pertama ialah velocity of flow. Kita akan mencari velocity iaitu A. Area, Q ialah flow rate. Formula untuk mencari area ialah pi d kuasa 2 bahagi dengan 4 bersamaan dengan pi kali dengan 0.45 kuasa 2 bahagi dengan 4. Jadi jawapan untuk A ialah 0.159. Jawapan untuk area ialah 0.159 bahagi dengan flow rate iaitu 0.054. Jumlah velocity ialah 2.944 m per s. Soalan kedua ialah mencari Reynolds number. Formula untuk mencari Reynolds number ialah velocity darab dengan diameter bahagi dengan kinematic viscosity. Jumlah velocity ialah 2.944 darab dengan diameter iaitu 0.45 bahagi dengan kinematic viscosity 2.3 kali 10 negatif 4. Jawapannya ialah 5,760. Berdasarkan Reynolds number yang telah dikira tadi, soalan ketiga ialah type of flow. Turbulent ialah apabila 5,760 lebih daripada 4,500.